graduate student. It's actually kind of pretty. It almost looks like a snowfall here. And we have rows and rows of these almond trees. And the trees, too, are managed very much like a business. These trees are perfectly spaced in perfect rows. And they just go through tremendous distances. And when you get up high, you can actually see that the trees are like stripes, like white stripes, because we have one kind of tree that is the almonds that people like to eat, and then two other varieties on either side that are the almonds that are necessary to pollinate that desirable. So you have one tree that's just coming into bloom, one stripe of trees that's in full bloom, and one stripe of trees that's passing out of bloom. And it's a very interesting pattern, and it's all designed to really maximize the almond pollination and all the almond production. And almonds has been a very vigorous industry over the years. The almond growers have done very well. The number of acres has increased tremendously, and except for some occasional weather-related problems, it's been a very profitable crop. We're seeing some problems coming up that indicate that things are not going quite as smoothly now and perhaps in the future as they have been at the time. And these pallets then are moved into the orchard, again by forklift, and spread at special distances that are predetermined by the density of the orchard and the size of the orchard, so that they can maximize the pollination of the crop. And in some cases, the orchard owners will even apply herbicide to plants growing nearby, weeds along the roadside, for example. So the bees will only fly to the almonds. And they have no choice. Bees are not converted to other flora. And this will probably increase the pollination of almonds a little bit, but it also can hurt the bees because it's pulling away an alternative source of food for them. Okay. And this is sort of the big picture here across the country. You see these arrows here. For example, there are a lot of bees that produce honey in the northern plains states. They can produce well over 100 pounds per hive. They're in the northern plains states in the summer, and for example, clover and sunflower and canola and some other crops here. And it's a good place to be in the summertime. Early spring in California, they will sometimes go over the Sierra Nevada mountains and the Rocky Mountains in January to get in this crop here in February. Up in the Northwest, we have a lot of fruit crops. Up in the Northeast, we have a lot of other crops. Blueberries and cranberries are pollinated oftentimes by honeybees and also by other bees, and many beekeepers have contact with those growers. Many will go down to Florida for the winter. In fact, there's an enormous number of hives in Florida in the winter because they can make honey off of the orange trees, and they have a milder winter so that they can build up strength in the early spring and time to go all the way over to California, typically in January. And there are some beekeepers who have been overwintering in Florida, and they have a choice in the coming year to stay in Florida to, for example, pollinate watermelons, or move all the way to California to pollinate the almonds. And many times they will choose a 3,000-mile trip to California because the higher pollination fees make it more economic. And it tells a lot about the almond industry. It is really driving the beekeeping business on a commercial scale because the crop is done so well on this commercially in the grocery store. You can see a bag of almonds in the past that was as much as $7 or $8 for a 1 pound bag of almonds. It's gone down a little bit, but that actually says a lot about the commercial beekeeping industry in the United States. And since the almond industry is increasing, that means a greater need for honeybees for pollination, and that means bees have been pulled away from other crops. Pollination fees have gone up, and in some cases there's been a real shortage of bees. Some of the beekeepers have gone so far as to import bees from Australia. And in the short term, this does provide the bees necessary for the crop pollination, but in the long term, this is a very real chance of bringing new pests and diseases from this part of the world. And we do have many pests and many diseases in honeybees. Most of them have come from other parts of the world, and these have become very serious issues, especially over the last 20 years, for beekeepers, including the small scale beekeepers. This is what it looks like in a cherry orchard up in the Pacific Northwest. Again, this guy just back in the beehive. You see it's late in the day, and the sun's actually going down over here. And he likes to move his hives late in the day because that's when the bees are inside the hive. They're not going to be able to feed them when it's bouncing around so much. And then in the morning, he can remove the students from the entrances to the hives and let the bees come out and fly in the first light of the day in the morning. They will take the orientation flights, fly around, and eventually settle and pollinate these fruit trees. So it's quite a business, and it's done somewhat the same way in some of the other countries like Canada and Australia. But Americans really do move their bees more than any other country. Really do push their bees very hard. There's many moves across enormous distances, and we do see that we have some factors that have come into play because of this tremendous movement of bees around the country, importation of bees, stress and the crowding really of bees by nature is not very good. Okay, this is here probably the main reason that this Pennsylvania beekeeper is losing so many bees. There's probably some other factors that play too, but this is one of them. This is a picture taken through the microscope, and these little white ovals, like this one right up here, are microbes that we call ceramic. It's a microbe that affects the stomach lining of the honeybee. There are many related microbes that affect other insects, other creatures, usually in the stomach lining, and they multiply and it's very hard for animals to digest food, thrive, and they are shed even when the animal dies, some of these microbes are actually used for biological control. Gypsy moth, which is very common in the forests in the United States, can be controlled to a certain extent by related organisms. We've also looked at some of these pathogens to control mosquitoes, grasshoppers, other sorts of pests. In this case, the microbe is the bad guy, the honeybee is the good guy, and we're looking at ways to control this microbe. If you look at this very long, thin line that's coming all the way down here, that is actually polar filament. It's like a harpoon. The spore will shoot out. What happens is, the spore initially has this very long filament wrapped up inside of numerous coils. And then, under the right conditions, pressure builds up inside of that spore. This very long filament, it's about 100 to the micron diameter, it's shooting out very quickly. And this is not even, I couldn't get it all on review in the same microscope. It actually comes down to about here. And that then will stab the stomach lining of the honeybee, start the infection. And the insides of this little spore, believe it or not, once you travel through this filament, this tremendous distance, and enter the honeybee cell, where it basically takes over. It begins to parasitize that cell, it begins to divide again, spread into neighboring cells, and if the bee ingests a lot of these spores, it's going to have a very serious problem. There's food well, less famous less, and you see a huge decline in the population over time. And this is what's happening in many hives, not just the commercial beekeepers, there are small-scale convincing beekeepers that have this problem. Also, probably by buying bees from other beekeeping operations, buying bees from other states. There are some companies that specialize in rearing and selling bees to beekeepers. They can also do the source and comparison. So what we're seeing then is one particular bee with perhaps 10 million or 20 million of these spores developing inside of it before that bee actually dies. And that time, of course, that pass to other bees, and it can pass to neighboring hives too, because the bees will sometimes fly out of one hive and then come into another hive nearby. This way the person very easily. And this is what it kind of looks like inside the bee.